In this video, we're going to introduce uneven cash flow streams and talk about how to use the HP10BII financial calculator in order to solve for the present value or future value of an uneven cash flow stream, as well as to estimate the implied discount rate associated with an uneven cash flow stream. So let's go ahead and introduce a little example. Let's pretend you're offered an investment that's going to pay you $300 per year for years 1 through 4, $600 per year for years 5 and 6, $2,000 per year in year 7, and $300 per year for years 8 through 10. You feel a 5% required return is appropriate. What is the cash flow stream worth to you today? Now, this is a problem that you could do with the 5-key approach, but it would take you quite a while and you'd have to do a lot of separate calculations in order to solve for it. So it's a lot easier to use a function in the financial calculator referred to as the cash flow worksheet or cash flow register. But before we do that, I want to introduce the idea of a timeline. A timeline is just a graphical or visual representation of what the cash flow stream looks like. So what we've done here is, instead of expressing it in words, 300 per year for years 1 through 4, we just put those out on our timeline. Then we had 600 per year in years 5 and 6, 2,000 in year 7, and 300 per year in years 8, 9, and 10. Our required return was 5%, so we note that on our timeline. Now, a couple other things to note on this timeline. One is that if we look at our sample problem again, notice there is no year 0 cash flow given. We start with 300 per year for years 1 through 4, move on, and we're not given a year 0 cash flow. But when we start plugging these values into our financial calculator, we're going to need a year 0 cash flow. So I'm just going to go ahead and write that in there. Year 0, our initial cash flow is 0. Second thing with the timeline is that these dashes, or hash marks, represent the end of each year. So this is the end of year 1, not the beginning of year 1. A lot of times students will want to make this the beginning of year 1, but the space here represents the year. The hash mark marks the end of the year. So this is the end of year 1 or the beginning of year 2. This is year 2, end of year 2. So we're getting $300 at the end of year 1, another $300 at the end of year 2, and so on as we move through our timeline. Now, in my mind, a timeline is a tool. As with any tool, use it if it helps you, but if it's not helping you, don't use it. I'm never going to require my students to draw a timeline for class. Instead, if it's something that you find useful, draw it. If not, ignore it. Sometimes you'll find the timeline can be very helpful, especially as you have a more complex cash flow stream. Sometimes you may not find it useful at all. Now let's go into our financial calculator and talk about how to set that up in the HP10BII calculator. Now, the first thing I did here is set up what the sequence should look like in your calculator. And if you want to take a second right now, you can pause the video, go ahead and write that down, and that way you'll have it with you as we walk through the rest of this video. Okay, now let me explain a couple things before we start punching the buttons into our calculator. First thing that's very important is that in the cash flow worksheet or cash flow register, cash flows stay in there until they're cleared out. So if you did a problem a week ago or a month ago and it's got more cash flows than what we're putting in here, this will overwrite the cash flows initially, but those extra cash flows are still going to show up and it's going to give you the wrong answer. So it's very critical that whenever you do a cash flow worksheet problem, a cash flow register problem, first thing you do is clear out the worksheet, then start putting in your cash flows before you try to solve for the solution. You skip this step, there's a very good chance you're going to have the wrong answer at the end. So let's go ahead and get our calculator. Here we have the HP 10B2 financial calculator. Just going to go ahead and turn that calculator on. And remember, the first thing I wanted to do was clear that out. So in order to clear out the calculator, I want to use that clear all button, which note that's a shift. So we've got to do shift, clear all. And when you do that, if you hold down, remember it'll show you what your periods per year is set for. And for this problem, we want to make sure that's 1. Now we've cleared out our worksheet. It's time to start entering our cash flows. Remember, before I said we start with year 0 cash flow. And to enter our cash flows, we're going to use this CFJ button here. So, first thing I want to do, tell the calculator 0 CFJ. So just press 0, then press that CFJ button, and that goes in as the initial cash flow. Then I want to go here to 300. That's my first sequence. So 300, and again press that CFJ button. Now that CFJ is not for necessarily cash flow 1, that's the first sequence. So we have that cash flow for 1, 2, 3, 4 times. So that's the next thing we've got to tell the calculator. What is the frequency of that cash flow stream? And to enter the frequency, we use the N sub J button. That's the shift of the CFJ. So again, shift and N sub J to put that in. Now we've got 4, so 4, shift, N sub J, and now we've got in that first sequence. Now we're ready for the second sequence, 600 for 2 years. So 600, CFJ, sequence is 2, shift, N sub J. Then we've got 2000. So 2000, CFJ. Now you saw that 3 flash up there briefly. That's telling us it's the third sequence. Now note our 2000, we only have 1 time. The default assumption on the calculator is if you don't tell it the frequency, it assumes that it's for 1 period and only 1 period. Well, that's all we want. So we don't have to enter the N sub J this time. It already knows it's 1 unless we tell it otherwise. So now we can go straight to the next cash flow sequence, which is 300 per year for the last 3 years. So 300, CFJ, 3, shift, and sub J. Now all our cash flows are entered. If you look back at our sequence, we've put all the cash flows in. Now we're down here, we need to tell it our discount rate and then solve for what's called the net present value. Now the discount rate is just plugged in as your interest per year, just like we did in the 5 key approach. That was 5%, so 5 interest per year. Now we want to solve for the NPV. You can see that here in your calculator. It's a shift function. So shift NPV. And there's our answer, $3,983.60. So we know that this cash flow stream that we introduced is worth $3,983.60. Somebody was willing to offer us that for $4,000, we wouldn't pay it. It's overpriced. On the other hand, if they were going to offer it to us for $3,700, it would be a bargain because we know it's worth $3,983.60. Now let's follow up a slightly different question. Now, assume that we're offered this investment for $3,000. Now we know if our required return is 5%, we should buy it because that's a lot less than the $3,983.60 we said it was worth. But we might want to know, how good of a deal is this? What rate of return are we actually getting? So we can solve for that. If you're offered the investment for $3,000, what is your rate of return? In order to figure that out, again, let's go back to the timeline. But now in our timeline, this year zero cash flow, instead of setting it as 0, we're going to set it up as negative 3,000 because we have to pay $3,000 today in order to get these remaining cash flows. So we give up 3,000, we get these cash flows back. Now note, that's got to be negative. If you don't enter that as negative, you're going to get an error message, no solution, because the calculator can't figure out an interest rate that allows you to get 3,000 today and get those cash flows. You have to give the 3,000 up in order to get that cash flow sequence. So now we want to look at what are the keystrokes that we have to enter into our financial calculator in order to solve for that rate of return. And this is the process here. Again, if you want to take a second and copy that down, you're welcome to. I'll go ahead and let you pause the video here temporarily. Okay, now note the first thing we do with any uneven cash flow stream problem, clear out the financial calculator. Now, while these cash flows are ones that we already entered and we want in there, this one wasn't. And with the HP10B, there's not an easy way to just replace the CF0. So we've got to clear it out and then put all those cash flows back in. So we have our calculator. First thing we want to do, Shift, clear all, clears out our financial calculator. Now we can start putting in our cash flows. Remember our year zero cash flow is that negative $3,000. So 3,000. Make sure we use our plus minus key here to make it negative. And then CFJ. Now 300 per year for the first 4 years. So 300 CFJ, 4 shift and sub J. 600 for 2 periods. 600 CFJ, 2 shift and sub J. 2,000 for a single period. 2,000 CFJ. Remember the default is 1, so we don't have to put anything in there. And then 300 per year for the last 3 years. So 300 CFJ, 3 shift and sub J. Now all our cash flows are entered. Last thing we need to do is just solve for the internal rate of return. That's a shift function. You find it on your financial calculator. See it right up here. It's the shift of the CST button. So in order to solve for that, just do shift, internal rate of return per year. Takes a second to calculate and gives you your answer of 10.48%. So going back to our example, if we could buy this investment for $3,000, what rate of return should we expect? The answer is a 10.48% average annual rate of return over the 10-year life of the investment. So we can solve for the present value of a cash flow stream, or if we know how much the cash flow stream is going to cost us, we can figure out what rate of return we're going to get. Now another thing that we can do is figure out what our cash flow stream is going to be worth at some point in the future. So in this example, which I'm kind of using as like a retirement approximation, you're going to be saving money for the next 30 years, and you want to know how much you're going to have 30 years from now. So $2,500 per year for years 1 through 5, $5,000 per year for years 6 through 15, then $7,500 per year for years 16 through 30. These represent your savings, how much you're investing into your retirement plan. And we're going to assume these come at the end of each year. You're just making annual contributions. Now, in order to make this a little more complicated and give you a little more experience with your calculator and how to set up a time value money problem, I've added a couple extra twists to it. first one, instead of starting out with nothing, we're going to assume we already have $75,000 saved. And we're going to be making a one-time additional savings of $30,000 in year 10. Now this is a single additional cash flow. We're not making it every year, but just in addition to these savings, in addition to our $75,000, we're also going to be adding $30,000 at the end of 10 years. We anticipate earning a 7.25% rate of return. So how much are we going to have 30 years from now? What is the future value of this cash flow stream? Before we get to that, let's just take a look at what the cash flow stream looks like. Now again, here's an area where I think the timeline can be helpful because there's a lot of different cash flows going on, so this can help us visualize that. Year 0, we start out with $75,000. Now note that $75,000 in this example is not negative $75,000. It's positive, just like all the other cash flows. The reason is all these cash flows are going in the same direction, so they need to be the same sign. You could make them all negative if you wanted to represent cash outflows, but it's just easier to remember. They all go the same sign. You don't have to make every single one of them negative. Just leave them all positive when you solve for your net present value. So here we have our cash flow, $75,000 initially, $2,500 per year in years 1 through 5. That came from our example. And then $5,000 per year for years 6 through 15. But remember, we also had $30,000 in year 10. So we have $5,000 per year all the way across, but in year 10 we have $35,000. That kind of breaks up the sequence, so we're going to actually have to enter it as 3 separate sequences. $5,000 per year in year 6 through 9, $35,000 in year 10, and then continue the $5,000 per year in years 11 through 15. Finally, we have our $75,000 per year for years 16 through 30. So that's at the end of our timeline here. And our discount rate is the 7.25% expected rate of return that we plan to earn. Now, one other thing I want to note on this timeline is if you notice on my previous timeline I had each year marked out specifically. However, this time I don't put in a hash mark for year 2, year 3, year 4. Just year 1 and 5, and kind of a line to indicate we've got those cash flows all the way. I want to put in the key cash flow points or the key years and label those cash flows. But if I wanted to put in the hash marks for each year and write in the cash flow each year, it's going to take me an extra 5 minutes to set up my timeline. It's a lot more convenient to just shortcut. Use the $7,500 per year and note that's every year from year 16 through 30 by using this arrow. So if you want to be more precise, you can, but remember, it's going to take you more time to set up your timeline. This just quick overview helps us visualize the cash flow sequence. Now, one other thing I did here is just kind of summarize what are we going to be putting into our calculator. Our year 0 initial cash flow is $75,000. Years 1 through 5 is our $2,500 per year. That represents a sequence of $2,500 for 5 years. Years 6 through 9, we have $5,000 per year. It's 4 years. Now you want to be careful here. This is a common place I see students make mistake. Is real quick in your head you want to do 9 minus 6 and say, well, that's 3 years. But we have to be careful. Those are inclusive years. So we actually have 4 years. Might look a little bit silly, but sometimes I tell students, go ahead and count them out on your fingers if you want to. You've got year 6, 7, 8, 9. You've got 4 years there. Another trick is just take the 9 minus 6 and then always add 1. So we've got 4 years of 5,000. Then we've got a single cash flow, just that year 10 of 35,000, so 1 year. Then we've got years 11 through 15, 5,000 per year for 5 years. Again, if we think of the trick, 15 minus 11 is 4. Add 1, that's going to give us 5 years. Years 16 through 30, 7,500 per year for 15 years. Again, another way to double check that you've got your year counts right. Remember, we've got a 30-year timeline here, stretches out to 30 years. So let's add up our total frequencies here. 5 plus 4 is 9, plus 1 is 10, plus 5 is 15, plus 15 is 30. That's a match. So we've got all the years accounted for. So now let's go to our financial calculator. And again, I've got the sequence on here. Go ahead and calculate the present value. Get that so it all fits on the screen there. And if you want to, you can pause the video here, calculate or write that down. Now, one thing you might be thinking is this is supposed to calculate the future value, how much I'm going to have after 30 years. But if you look, I've calculated the net present value. I don't want to know what it's worth today, so why am I calculating a present value? I want a future value. Well, some financial calculators have a net future value button, but the ones we're using for this class don't. So instead, you need to do kind of a little shortcut or cheat around that and say, well, if we know what the cash flow stream is worth today, we know its present value, then we can just bring that forward till the end and figure out its future value. Just like any other cash flow, if you know what it's worth today, you can figure out what it's going to be worth at a later point. So what we're doing here is actually a two-step sequence. First of all, we're going to calculate the present value of the cash flow stream by getting our net present value. Once we do that, we're going to bring that forward to the end of the timeline. So we need to bring it forward to year 30. And we're going to do that with the 5 key approach. So get the present value and then go ahead and get the future value. Two-step process. A lot of times on exams, if I ask students for the future value, they'll do the first step. Forget the last. You can't forget that last step. You need to give me the future value if that's what I'm asking for. So let's go ahead, get our timeline out, look at our sequences, and put those into our calculator again. Remember, first thing we need to do is always clear out our cash flow worksheet. So Shift, clear all, and now we can start putting in our cash flows. We start with that 75,000. Is your year 0 cash flow. So 75,000 CFJ, put that in. Then we have 2,500 per year for 5 years. So 2,500 CFJ, 5, Shift, and sub J. Now we're ready to go to our second sequence, which is 5,000 per year for 4 years. So 5,000 CFJ was for 4 years. So 4, Shift, and sub J. Now we have our 35,000 in year 10. That's only 1 year. Remember, when we have a frequency of 1, we don't have to put in the n sub j. It defaults to that. So 35,000 CFJ. Don't need an n sub j. We can go right to our next sequence, which is 5,000 per year for 5 years. So 5,000 CFJ. We need that for 5, Shift, and sub j. And lastly, we have our 7,500 per year for 15 years. So 7,500 CFJ. We need a n sub j of 15, Shift, n sub j. Now all our cash flows are entered. Once our cash flows are entered, we want to put in the discount rate, solve for NPV. So put in the discount rate here of 7.25. Remember, you put that in using the interest per year. And now we just want to solve for NPV, which is a shift function. So Shift, NPV. And that gives us our answer of $148,079.36. I'm just going to go ahead and write that down. $148,079.36. Remember, what we've done effectively is we've brought all these cash flows back to year 0. We figured out what they're worth today. What we want to know is what they're worth in year 30. So now we do the last step, bring that today forward 30 years and figure out what it's worth. We're going to do that with the 5-key approach. So again, this is just a basic 5-key calculation. We've got a 30-year time horizon, so 30 is our N. Our rate of return is 7.25%. Our present value is that $148,079.36. So put that in as our PV. We don't have an annuity stream because we've taken all these cash flows, brought them back to a single value. So there is no additional cash flows. So just zero out the annuity. And now we want to solve for future value. So this cash flow stream is going to be worth $1,208,964.52 to us at the end. So let me just write that down. $1,208,964.52. If this was a retirement savings plan and we were actually able to make those savings over the next 30 years, earn our 7.25%, at the end of 30 years, we're going to have a little over $1.2 million waiting for us at retirement. So this video, again, just a quick reminder, had us look at uneven cash flow streams, calculate the present value of those cash flow streams, solve for rates of return, or solve for the future value of an uneven cash flow stream. Hopefully this helps you. If you have any questions, please let me know.